Welcome to the first in a series of short videos introducing the concepts of chemistry. Chemistry is the study of the structure and the interactions of matter. In this video, we'll start off by looking at the smallest unique particle of matter, the atom. The atom is the smallest particle of matter that is chemically and physically distinguishable. However, it is not the smallest particle of matter that exists. Atoms are made up of three fundamental particles. The first one is the proton. All protons in the universe are identical, and by definition, they define matter. A proton has a mass of exactly 1 atomic mass unit. It also has a charge of +1. Chemically speaking, the proton is the fundamental unit, because the number of protons defines the element. Z is the number of protons in a nucleus, and this is the atomic number. The second fundamental particle is the neutron. A neutron is slightly heavier than a proton with a mass of approximately 1 AMU, and as the name implies, it has a charge of 0. Also, protons and neutrons make up the nucleus of the atom. Therefore, you have another term called the atomic mass associated with any given atom, which is the number of protons plus neutrons. The number of protons is fixed for any given element, but the number of neutrons can be variable. This leads to particles called isotopes. Isotopes are atoms of the same atom, meaning that they have the same number of protons. However, they have different masses. This occurs because they have different number of neutrons and therefore different atomic masses. The third particle present in the atom is the electron. The electron is often symbolized by a lowercase e. An electron essentially has a mass of 0 and a charge of -1. Chemistry is essentially the study of the movement and exchange of electrons. Electrons can be either given, taken, or shared, leading to chemical reactions. Therefore, the number of electrons in any given atom is a variable. They orbit the nucleus and can produce what are called ions, electrically charged atoms, by adding or subtracting electrons. If one has a neutral atom, that means the positives and negatives cancel, and the number of protons and electrons are equal. A negatively charged atom has excess electrons. This is called an anion. A positively charged atom has lost electrons and now has a positive charge. This is called a cation. The way that protons, neutrons, and electrons interact are found in the periodic table. The periodic table is a list of all of the elements found in nature. Like any other list, it goes box to box, and those boxes are numbered 1, 2, 3, 4, 5, and so on. Those numbers are the atomic numbers, or the number of protons in any given atom. For example, when one fills in the elements, one sees that carbon is element number 6. This means that every atom in the universe that has 6 protons is a carbon, and every carbon in the universe has exactly 6 protons. Below the symbol, you have an average atomic mass of protons and neutrons for each element. This should be noted once again is the average mass. So one sees in the case of chlorine, average mass of 35.45, which is a weighted average. Chlorine comes in 2 isotopes, chlorine 37 and chlorine 35. As both of these isotopes are chlorine atoms, that means they will both have 17 protons. However, they differ in their atomic mass. In the first case, I have a mass of 37. Since chlorine has 17 protons, that means that chlorine 37 has 20 neutrons. Similarly, chlorine 35 with 17 protons, 17 plus 18 neutrons adds up to the 35. Isotopes exist in nature in varying quantities. That's not necessarily a 50-50 split. They come in various ratios. For example, in chlorine 37 has an abundance of 22.5%, and chlorine 35 is 77.5%. So, to get the weighted average, one very simply takes 22.5% of 37 and 77.5% of 35, and then arrives at the average weight that's given on the periodic table of 35.45. Once you have atoms, they actually have to do something. The thing that they do, which makes life possible, is they form compounds. These compounds are defined by a chemical formula, which are the ratio of the number of atoms in any given compound. For very common compounds, such as water, everybody knows the formula for water is H2O. That is very simply a statement of every water molecule has 2 hydrogen atoms for every 1 oxygen atom. Another common compound, table salt, sodium chloride. The formula is NaCl, which tells you that for 1 sodium atom, there's 1 chloride ion rather. This seems fairly straightforward. So if I take 1 sodium plus ion and 1 chloride minus 1 ion, I will make 1 sodium chloride. However, exactly how one does this is actually more complicated, because looking at the periodic table, one sees sodium weighs roughly 23 AMU and chlorine weighs 35.45. These 2 atoms do not weigh the same. Therefore, you cannot simply weigh them to determine what a 1-to-1 ratio is. The question is, since mass does not necessarily equal the number of atoms, how does one find out how many atoms are in any given compound, and how does one do chemistry? Is it possible for a scientist to take a very large magnifying glass and simply count 1 atom at a time and glue them together? The answer to this is obviously no. There has to be a simpler way of counting atoms, and that simpler way is found known as the mole. Although it has an odd name, a mole is very simply a ratio. Much like there are 12 eggs in a dozen, the mole is the ratio of the mass in grams to the number of atoms that are present. How the mole can be calculated is fairly simple. One starts with the simplest elements. By definition, hydrogen weighs exactly 1 AMU. So, conceptually simple, although practically difficult, the question is, how many hydrogen atoms do I need to get to 1 gram? Skipping over how this was determined, one finds that number is 6.022 times 10 to the 23rd. This number, which is fundamentally important, is called Avogadro's number. It is the way that one can translate mass into the number of atoms. So, if I take any given element on the periodic table, hydrogen with a mass of 1.008 AMU would have a molar mass of 1.008 grams in 1 mole. Carbon with a weight of 12.01 AMU, 1 mole would weigh 12.01 grams. Oxygen at 16 AMU would have 1 mole weighing 16 grams. Sodium, 22.99, would weigh 22.99 grams per mole. Chlorine, 35.45 AMU, would have 1 mole weighing 35.45 grams. This not only helps with the atoms themselves, it also helps with the compounds. So if I have 1 mole of water, water is composed of 2 hydrogens and 1 oxygen. In other words, 2 times 1.008 plus 1 times 16, water would weigh 18.016 grams per mole. Sodium chloride, similarly, has 1 sodium and 1 chloride atom in it. Since the sodium weighs 22.99 and the chlorine 35.45, sodium chloride would have a mass of 58.44 grams per mole. Even when one gets to more complicated compounds, such as simple sugars, C6H12O6 has 6 carbons, 12 hydrogens, and 6 oxygens. So that would be 6 times 12.01 for 12 and 12 hydrogens, 12 times 1.008, and 6 oxygens, 6 times 16, would give glucose 180.16 grams per mole as the molar mass. Summary. Essentially, chemistry is a game of ratios. The mole is the number of atoms to the mass. The chemical formula is the ratio of the number of atoms in a given compound. As each atom weighs different, if you're counting atoms, it is important to always convert grams to moles. This can be seen with a very simple problem. I have an identical weight of hydrogen and helium. Does that mean I have the same amounts of hydrogen and helium? If I look at the 2 elements in question, according to the question, I have 1 gram of each. The mass is identical. However, helium is the heavier element. Hydrogen weighs 1.008, while helium weighs 4.003 grams per mole. To convert to moles, you have to make sure your units cancel. 1 divides grams by grams per mole, and one sees that one actually has 4 times as much hydrogen as helium in the sample because the hydrogen is heavier. Grams are not useful in determining how much of a material you have. Everything has to be converted to moles if one is going to relate masses and atoms and elements in chemistry. The following video, you will see how one uses these relationships to perform chemical reactions. The following video is linked in the description below, and I hope you found this video useful. Thank you for listening.